Hello friends and welcome back to Purus Tech Java tutorials, and in this session we are going to cover one of the OOPS concept, that is inheritance. So there are four main concepts of object oriented programming, that is abstraction, encapsulation, inheritance and polymorphism, out of which we will discuss about today, that is that inheritance. So let's see what is inheritance and how we can achieve this. Let's write a Java class. Okay, before writing to this Java class, let me just tell you one scenario where we can use the Java inheritance. Let's say I have a simple calculator where I have the functions like addition, subtraction, multiplication, division. Let's say, for example. So at the beginning, I have a simple calculator, but after some time or some duration, I wanted to get a scientific calculator. So scientific, what it has? It has everything whatever simple calculator has. Along with that, there are some other functions, that is exponential, factorial, mod, like this. So let's try to understand how we can demonstrate this simple calculator to advanced calculator, that is scientific calculator implementation using inheritance. So here the standard calculator is having these functions, which is automatically it is embedded in the scientific. So the common are these functions, right? The common are this function which is in between the scientific and the normal standard calculator. So let's define one standard calculator. Okay, and what kind of functions it can do, or what kind of method it can have? It can have the add, subtract. Let's say, for example, we'll take only two methods: public void add, and it takes two parameters, integer a, integer b. So instead of a and b, let's write first number, this is second number, like this. Subtract. So let's add only these two, add and subtract, for simplicity. Okay, so I want a, scientific calculator also, which can have actually this add, subtracts, multiplication. I didn't write, but let's assume it. And I can actually make use of this standard calculator inside that scientific calculator. Let's try to write one scientific calculator. So scientific calculator, what it can have? Let's assume we will not use inheritance right now. We can see how it can be leveraged in this particular example. So I can just copy and paste these two methods here, and I can write one more method, let's say factorial. Integer input number, and here let's write here system out println find addition or add two numbers. So this is just for simplicity. I have just implemented like it will just print add two numbers, and here let's subtract two numbers, and here I can write find the factorial of a number. Okay, so this is what I can achieve. Let's write one main method here. So to call this particular method, what I need to do, I need to create an object here, scientific calculator sc equal to new scientific calculator, and let's say I just wanted to uh, find the factorial of a number, then I just write find factorial. I need to pass a number since I have a parameter input number. So let's say I want to find the factorial of 5, then what it will happen, it is just let's add it, let's utilize this particular parameter here, input number, right? Add two numbers here also, let's add first number and comma second number. Let's copy paste this one also. Okay, now let's try to run this program and let's see what happens. So it should actually call this find factorial. What you should do, control, and if you just press control key and then move your cursor, it will highlight or underline the functions or methods. So if you control and click, it will go to the particular method. So it should actually print find the factorial of number 5, which I am giving the input. Let's try to run this. Okay, here is the output, find the factorial of a number 5. Now let's see what it prints when I say for sc.add. Then I need to pass 5 and 6. Let's say two integer variable it is expecting. So I need to pass two integer variables here. And if I run this program, it will print like add two numbers first, that is 5 and comma 6. So here is the output. Now let's see how we can use the inheritance to get some of the properties or some of the behaviors in the sense the methods. So let's put a PSVM public static void main in this scientific normal standard calculator. And if I'll say just copy paste, and this method does not exist, so let me just delete this. And here if I run this program, what it will print? It will print the same, like add two numbers 5 comma 6. Now you can see these two methods logic or the functions are same as in scientific calculator. So what it is happening, there is a duplication of code here and here, right? These two methods does the same function what the standard calculator add and subtract has. So using inheritance, what I can do is I can remove this duplication of code in these two classes. Let's see how to do, how to utilize these two methods in our scientific calculator to make it work. So I have to say extends. So extends is a keyword. So what it extends? It extends a standard calculator. Now as you can see, the standard calculator already has these two methods. I don't need these two methods because it extends this standard calculator. By default, these two method will come and reside in this particular scientific calculator. So what I will do, I will just delete these two codes or two methods from here, and then I will run this program. Let's see what happens. So as you can see here, it is calling the find factorial which is there in this particular class, and it is printing find factorial of number 5. But as you can see here, add method is not at all there in this particular class. So from where it is coming from? It is coming from this standard calculator. So these two methods are dynamically added into this scientific calculator to make it work. So this is the power of inheritance. You are inheriting the properties or the behaviors in the second class. So this class is called the superclass, and this class is called the subclass in Java. So what is a subclass? Subclass extends the superclass to get some functionality from the superclass itself. I hope this is clear. And likewise, what we can do, this is the behavior what we have achieved. Now let's see on the property fields. So let's assume integer, there is an integer value x equal 10, and here I don't have any integer. Let's define here one double value, double t equal to 1.5. Okay, now if I wanted to print sc dot, as you can see here, there are two variables d and, let me go back, control and space, so d and x. So d is directly coming from this scientific calculator, whereas the x is coming from your standard calculator. So this is the power of inheritance. You can make use of these methods as well as any property defined in the superclass in the subclass itself. So let's try to print it. sc.x sysout, and let's run this program. See, it is printing 10. So what is the value of x? It is not defined here, but it is defined in the superclass level. If you come here and do a control, press the control button and go here to the x and click here, it will take you to the superclass integer value. So this is the one of the most important OOPS concept in Java, that is inheritance. Yep. So thanks for watching this video. We will cover in the next sessions like abstraction, encapsulation, polymorphism, what is that and how to achieve it. So for that, stay tuned. Thank you.